Assalamu alaikum. Okay, today inshallah we will continue with last subject. We still in normalization subject. Before we start, let me speak a little bit about our midterm exam. There is a few issues. First issue, some students answer the relational algebra from left to right. Actually, the correct, it should be answered from right to left. So this makes the marking more difficult when you write relational algebra from left to right. Another issue, there is 2 or 3 students just brought answer from internet for the questions, and actually this answer was wrong because they just search about the subject. Actually, yeah, it's impossible that I will bring a question as it from the internet and put it in your exam. So don't imagine that you just search for the subject in the internet and you find any answers that it will be correct. Actually, most question or all the question, I write it myself. Even relational algebra, I write it myself, everything. So only maybe AR diagram, I brought okay some description, but I changed it too much. So you will not get the same answer if you search from the internet. I tried to give you reasonable midterm exam. Even, for example, relational algebra, I made it very easy, actually. Third issue, there is some students used union and intersect, but they missed one very important information, that union and intersect, the relation should be compatible, okay? Should be union compatible. And another thing, union and intersect and this type of relational algebra operation, it's on the tables, not attributes. So you cannot, union do not mean that if you have in relation X, you have attribute A and B, and in relation Y, you have attributes C and D. If you make union, then you have attributes A, B, C, D. No, it's not correct. Actually, it's union for tables, for row, not for columns. And the intersect, it's, and also it's for tables. So it should be union compatible for all this type of relational algebra operation. Actually, the correct way to connect between two relations to get attributes, they join. Okay, and I made it easy for you because I made all the foreign key and the primary key same name, so you just need to make natural join without any condition, because you have the attributes foreign key and the primary key same name. Okay, that's all. If you have any question about midterm exam before we start, please go ahead.
Doctor, I don't have a question, but about the time. The time is very limited, and I hope for the final it will be 2 hours instead of 1.5 hours.
No, there is many students get very good marks and answer everything. Okay, if you waste some of your time, let me continue. If you waste some of your time searching for the answer from the note or from anywhere else, or discussing or something like this, of course you will not have time. But if you already studied well and you just need to understand the question and answer the questions, the time more than enough. I know that.
And for the final,
I'm sure about the time actually.
For the final, we will be responsible for the new topics or for the whole topics, for the general.
For the final,
In the final,
yes. When we reach the final, we speak about the final. I don't have any idea now. Okay, it's still very early to speak about the final. Okay, let's continue now.
Okay, thank you.
Okay, any other question from other people? Enough for you.
No question, Doctor. Please, you can head about a new lecture. Thank you.
Okay, then let's continue. Actually, we are late little bit because we waste 1 week with the midterm exam. So we stopped here, I think, in chapter 14. Just a very quick review so we can connect. Chapter 14 speak about normalization. We will focus, as I mentioned, about 4 normal form: first, second, third, and BCNF normal form. Okay, at the beginning, we spoke about guidelines. Okay, I don't want to repeat the guidelines. I will go directly to, you can read guideline or return to our previous video, but I will mention the 3 normal form: first, second, third normal form very quickly. Okay, we reach, I think, here. Until now, we spoke about the 3 normal form: first, second, and third normal form. First normal form, it said that all attributes depend on the key, and all attributes should be atomic value, should have atomic value. This means if you have multi-valued attribute, it should be separated in another relation. If you have a composite attribute, you have to divide it into simple attribute. Okay, so almost you will have first normal form if you have all values atomic. Then second normal form, all attributes depend on the whole key. This means if you have partial functional dependency, you have to divide it or take it in another relation. Third normal form, all turn off your mic. لا إله إلا الله. Muhammad Sultan, turn off your mic.
Sorry, Dr.
Okay. About third normal form, all attributes depend on nothing but the key. So all the attributes should depend only on the key. Okay, so we should not have partial dependency. Here we should not have partial, here all attributes depend on the whole key. We should not have partial dependency. All attributes should depend on nothing but the key. This means we should not have a transit dependency. This means that if we have some attributes depend on another attribute, not the key. So we should remove this type of dependency or functional dependency. We will take a full example after finish BCNF. BCNF, actually it's like this. BCNF, if we have functional dependency X, determines A, this means X should be a super key, or sorry, do you have a question? Okay, all the functional dependencies to be in BCNF normal form, the determinants here should be super key. This means should be primary key or any candidate key. This means if you find a functional dependency, actually, if you look to the third normal form, you will say, okay, we will not have something like this because we said if it's in the third normal form, then all attributes depend on nothing but the key. Here, it's few cases that you will have a relation not in the BCNF. This cases not for the normal attribute. Sometimes you will find normal attribute, okay, determine part from the key. So if you find like this, for example, you have relation A, B have attributes A, B, C, and you have the key A, B. Then when you find like this, normal attribute determines part from the key. Actually, this relation like this, it's in the third normal form because you cannot consider this as a partial dependency because this not part from the key. Okay, and it's not transitive dependency because this determine part from the key, not another normal object. So attribute. I will show you the different. If we have A, B, C, and A only the key, then C determines B. This is transitive dependency because C normal attribute, B normal attribute, or we called it non-prime attribute. Non-prime, let me just check the name. Okay, non-prime attribute. We already mentioned it. If the attribute part from the key, we called it prime attribute. If not part from the key, we called it non-prime attribute. So if the relation like this from non-prime attribute to non-prime attribute, this means it's not in the third normal form. Because we have here transitive functional dependency. Here, the attribute C, it's non-prime attribute, but it's identify here part from the key, identify prime attribute. This one in the third normal form, but it's not in BC and F. Okay, we will see examples. Why? Because we mentioned that each functional dependency stronger than the previous one. So you cannot find second normal form before find first normal form, it's applied or not. So every second normal form, it's already in the first normal form. Every third normal form, it's already in the second normal form. Every BC and F, it's already in the third normal form. So it's like this. You have to start from the first until you reach BC and F. So BC and F have two conditions. The relation should be in the third normal form first, then should apply the condition of the BC and F normal form. That whenever you have functional dependency like this, X determines A, then X is a super key. If X, like this one, it's not a super key, it's not part from the key also, then it's not in BC and F. You will say, okay, this one also not super key. Yes, but you will not reach BC and F with this type of functional dependency because it's a transitive, so it will be solved during third normal form. But you can reach here BC and F with this type of functional dependency. So without memorize the definition here, how to identify it just from the first second. When you find any attribute determines part from the key, then you directly know that this functional dependency have problem with BC and F. Okay, then here example. Here consider that country name as candidate key. Here we have primary key, we have candidate key. So this functional dependency 5, it's actually not in BC and F. Actually, it's difficult to find a real example on BC and F. That's why you will find most examples like this ABC or some relation just for examples. But if you find real database system and you done the first, second, third normal form, it's difficult to find a problem with BCNF. That's why almost until BCNF, after this, it's very rare to use fifth normal form. Okay, so if you look to this relation, is it in first normal form? Yes. Is it in second normal form? Yes, because we don't have any partial dependency. This is the key, and this determines C, not part from the key determines C. C determines B, it's not a partial because C not part from the key. Okay, so it's in second normal form. About third normal form, C implies B, not the transitive dependency, because B is self part from the key. Okay, but is it in BCNF? No, it's not in BCNF. Why? Because C not a key and determines part from this key. So how to solve it? Actually, it's not easy as you think, because if you said I will take B and C and divide this relation, so this functional dependency one will be broken. So it's not easy to divide the relation that it's not in BCNF into two relations. We have specific algorithm, we will follow it, and after that, after take examples about these algorithms, I will give you a trick to find the solution even more quickly, the correct solution, because when you decompose this into two relations, there is a problem that we spoke about it in the first of this chapter. Last time we spoke about lossless join, that you have a problem when you decompose a relation into two relations. When you rejoin it, you will have a problem. We called it what we called it, I forget this name, spurious or fake tuples. When you rejoin, we already give example for this problem, you can return to it. That's why we have to be here, we have to take this into consideration. Okay, this is another example. This the student and course, it's the key, and it determines instructor in this example, and instructor determines the course. Here, this dependency have problem with BCNF. How to solve this one? Maybe I can divide this into two functional dependencies. We have two functional dependencies. Maybe we can divide it in three ways. Two ways have problem and one way correct. We will see the different. Why this one correct decomposition and why this two ways incorrect. just let me check this slide. Okay, okay. I said that student and course is the key of this relation. It's in third normal form. Okay, then we need to compose this into two relation, but when we divide this into two relation, we will lose this functional dependency. It's okay. We can lose one functional dependency, but we should not sacrifice the non-additivity property. This means when we add this decomposed relation again or join it again, we should not have the superuse tuples or fake tuples. Okay, so to divide it, to decompose it correctly, it's not easy, or it's easy, but it's not without following the correct step. Okay, let me mention it like this. So we can divide it like this: student with instructor, student with instructor, because students, okay, can determines instructor as we mentioned here, and students with courses. This means students with courses here alone. Okay, student with courses and student with instructor. Here, this functional dependency, we lost it. Every time we will lose one functional dependency, but which one we can lose without any problem, that's what we will learn. Course with instructor. So course determines instructor, and course with the student. Another way, instructor with course. So we have instructor determine course and instructor with the students. Actually, many ways to divide it, but which one is correct? We have to test it to find which one correct. Actually, this test, we called it NGB probability, non-additive join test for binary decomposition. I will make it short for you. It's about functional dependency. We will make union for functional dependency of the two decomposed relation. If we have one of the original functional dependency, then it's correct. If we don't have, then it's not correct. This is the mean of all this. Okay, functional dependency union for functional dependency for R1 and R2. This means when we divide the relation to R1 and R2. Okay. This term called F closure. This means the whole set of functional dependency. F closure for this one, if we call this FD1 and FD2, this is the F closure, FD1 plus FD2. Here, FD1, FD2, FD5, before any decomposition. Okay, the whole set of functional dependency, we called it F closure. So this means in short that we should find the functional dependency, one of the functional dependency of R2 or minus R1 or R1 minus R2. Let's see here what we have. Functional dependency, student and instructor. It's not part from the F closure. Here F closure, FD1, FD2. This student with instructor and student with course, also not part. Okay, so in this one, we don't have any functional dependency from the original set. In this one, course with instructor, course with instructor, and course with student. Also, it's not part from FD1 or FD2. Okay, let's check this one. Instructor with course, instructor with course. You see, it's same like functional dependency too. And instructor with the student, it's not from part from it, but we have one here. That's why third one, it's correct because we have at least one of the functional dependency here. Functional dependency from the first relation. It's part from the F closure. The whole set of the functional dependencies, which this one. That's why D3 or decomposition 3, it's the correct one. Because when we rejoin, it will give us a relation without spurious tuples or without fake tuples. Okay, this is difficult. Yes, I know it's difficult. How to solve it without, okay, make decomposition 1, 2, 3, and 4 and find which one it's the easiest one. Actually, there is this is what I described now. There is algorithm. It's actually come from chapter 15. Yes, this algorithm. This algorithm said, in short, I will make it short. If you have functional dependency, X determines A, and this functional dependency cause the violation with BC and F, cause the problem, like this one here. Which one caused the problem? This one. Instructor determines course because course part from the key. This one cause problem. Yes, this functional dependency. So this X and this A. X determines A. This has the problem. So when you found this, okay, functional dependency that cause the violation for BC and F, you can follow this rule to decompose it. Just 2 steps. R, this means the whole relation minus A. R minus A minus the determines or determined attribute, and this one will become R1. This one will become R2. It will be X, the attribute that determines attribute, union A. We don't speak here about the union from relational algebra. Okay, We speak about union between the attributes now. It's not relational algebra, okay? So, in our example, instructor determines course. This is a problem. Yes, here. Instructor determines course. This is a problem. And here X, here A. This means we have the relation teach minus A. Yes, this first relation R minus A. We have the relation named teach minus A. Which one A? Course. This means minus course. And relation 2, which is X, instructor union course. So we have teach minus course. We have only instructor and student remain here. Okay, instructor union course, instructor union course. Then this same as D3. Okay, but the question here, you will confuse little bit about what primary key I should take. Actually, this one you will take both as a primary key, and this one you will take X. X here, you will take X as a primary key. So X, okay, relation minus A. This means we have instructor and student, this first relation. Instructor with the student. And you take instructor as the primary key. And the other relation, instructor, this one, X union A. Instructor, instructor, and courses, and both of them will be primary key. Okay, we will take examples for this one. This example, okay, we have functional dependency, full functional dependency here. Okay, on the key. We have partial dependency because this is the key. This is the key. Focus. We have two elements as key, two attributes as key. So this part from the key determines employee name and birth, date of birth. Then this one, partial dependency. Part from the key, project code, determines project description and project supervisor. Then this partial dependency. And we have one transitive dependency because we have depth code. Okay, let me not using this one. We have depth code determines department name, and it's not part from the key. So non-primitive prime attribute determine non-prime attribute. That's why it's transitive dependency. Okay, then first thing, normalization should be from first, second, third, and so on. Okay, so I have to check first. Is it first normal form? Yes. All attributes depend on the key. Here, this full dependency. And all attributes atomic. Okay. Is it in second normal form? No. Why? Because we have partial dependency. Partial dependency means not all attributes depend on the whole key. Some depend on part from the key. This partial dependency. So it's not in second normal form. We have to solve it first. How to solve it? We take those attributes with the partial dependency with copy from the part from the key. And we take those attributes, we take it from here. So it will not exist here, but that the part from the key that, or this part from functional dependency that determines the other attribute, we will take just copy from it. So we will remove this, both of this into two relation with copy from this part, project code and employee code. Okay, so it will divide it like this. Copy from project code with project description and project supervisor. Project code with project description, project supervisor. And copy from employee, and we take here employee name and date of birth. Okay, then now we have 1, 2, 3 relation instead of one relation. Now it's in second normal form. All attributes depend on the whole key. Here, full functional dependency, full functional dependency. Now we can check third normal form. Is it not on the, it's not in the on the third normal form. Why? Because we have transitive dependency. Not all attributes depend on nothing but the key. We have here this attribute depend on non-prime attribute. So what's the solution? We take this attribute in another relation with copy from this attribute. So now we understand that determined attribute, we take it out. The determine attribute that determines this attribute, we take only copy. So this one will divide it into another two relation. We take copy from department code here, and we take out department name here. And we take, of course, the functional dependency. This become full functional dependency. Okay, then this one here, it's primary key, and this one foreign key. Okay, this one primary key, this one become as foreign key. Okay, and this one also here, primary key, and it's okay, it should be like this, because some students also foreign key, okay, should implies the primary key. And here it's also foreign key. It's part from primary key here, but also it's foreign key for this primary key, and this one same. Okay. Okay, the question here, it's in the third normal form now. Is it on BCNF? Yes. Why? Because all functional dependency determines by super key or primary key. All determines by, here determines by primary key. Here determines by primary key. here determines by primary key. Okay, you will said, okay, this one determines not from primary key. Okay, but this one transitive dependency. So we will remove it using this third normal form. So it will not reach the BCNF. The only way to reach the BCNF if this one part from the key. So it's not, it's become not transitive dependency. It will not removed by third normal form. Then you will reach BCNF and removed it. Okay, this example you can try it at home. Let me move to the next example. Okay, let's try to solve this example very quickly. We have this one, full functional dependency. Okay, this means first normal form. Okay. Okay, but you see here, we have here partial dependency and the transitive dependency. Because we have partial dependency, so it's not in the second normal form. How to make it second normal form? We will divide it into two relations. This one, to become in the second normal form, should be divided into two relations. First relation, we will take P address okay with copy from proprietary number. I will try to just make it shorter. Okay, this of course primary key here. Then this functional dependency FD2, and it's become full functional dependency. Okay, what remain here? We have proprietary number. We have IDate, and we have ITime, and we have comment. We have stuff number. I will continue down here because no space. And we have S name. And we have car rig. Okay. We have here proprietary number and IDate as primary key. This functional dependency one, it's okay. It's full functional dependency. Determine this one, and also this two. But we have problem that stuff number determine this FD3. FD3 determine as name. Yes, so this one not a key, this one not part from the key, so we have non-primitive attribute, determine non-primitive attribute, then this transitive dependency. How to solve it? We have to divide this into two parts. So we have relation R1 and we have relation R2. R2 will be divided into R2.1, let me name it like this, R2.2. So we have R2.1 that will have all the attribute, property, number with IDate, blah, 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 and stuff, number, and car reg. Now, actually, as name will take, I will take it into another relation. Why? Because it's transitive dependency on stuff number. So I will take it with copy from stuff number. So we have stuff number with S name. Stuff number here, the primary key, and this is the foreign key for it. Okay, same thing. This one part number, it's the primary key, and this one the foreign key, and this also primary key here. So we have third normal form now, which is R1, R21, R22. Sorry, because my handwriting here, it's difficult to write here and the space not enough. Okay, but I think it's very clear. Now, just the BCNF, we will take example with a simple trick to make it very easy to find the BCNF. Okay, this example for BCNF. Okay, consider that we have this relation or this table, student ID, professor ID, class code, and student grade. And we have this two functional dependency, FD1 and FD2. We will draw it like this. We have student ID and professor ID, it's the key. It determines class code and student grade. This FD1 do not have any problem. Okay, this one, we have a class code determines professor ID. This FD2. First question I will ask you, is it in the first normal form, this relation?
Yes, Doctor, it's there. It's in first number four, yes.
Yes, it's in first normal form. Why? Because this FD1, it's full functional dependency, and all these attributes determined by key. So it's in the first normal form. Is it in second normal form?
Yes, it's in the second number form, yes.
Oh, Doctor.
Yes. Why? Because we don't have partial dependency. There is no part from the key that determines any other attribute. Okay, is it in the third normal form? Yes, because all attributes depend only on the key, not sorry, because we don't have transitive dependency. All attributes depend on the key and only on the key. This means لا إله إلا الله.
استغفر الله.
Okay, cut my thinking fluency here. Okay, about third normal form. Third normal form that we don't have transitive dependency. Some students will say, okay, this one transitive dependency. Actually, transitive dependency, if we have non-prime attribute, determines non-prime attribute. But this non-prime attribute determines a prime attribute, this one part from the key. So it's actually on the third normal form. But we have problem with BC and F. Why? Because we have here non-prime attribute determines a prime attribute. This dependency, it's a problem with BC and F. So we have this functional dependency have the problem. So let's go to the answer directly. We have like this: if X determines A cause the problem, we will have the relation minus X minus A, and we have also X union with A. This should be the two relation when we divide it. Yes, so the answer like this: class code determines professor ID. This one, class code determines professor ID, cause the problem. Yes, so the procedure, we have two steps for the solution, or two relation, R1, R2. R1 will be the whole relation, which is class test relation. We called it the class test relation, minus A. Which one A here? This A, this X. Minus A, this mean minus professor ID. So this first part, we just remove professor ID. So we still have the relation. When we remove professor ID, this by the way, this one, the primary key, yes, before divide it. So we removed professor ID. We will have now student ID, class code, and student grade. Student ID, class code, student grade. Which one will be the primary key? If we still have part from primary key, of course we will have part plus A itself. X plus X. This one caused the problem. We removed A. Now remain X plus the part from the primary key. This is the primary key. As you see, even the procedure, it will have problem with you to identify what will be the primary key. I will give you more simple solution to find the primary key and even to divide it. Okay, but this is a formal solution. Actually, the other solution, not really formal, but it will give you the correct answer. Okay, then X union A, which is professor here, and X, which class code. Class code with the professor will be the primary key for the new relation. So we have class code with professor ID. It should be, oh, sorry, class code, because this one determines this one. So class code only. In the first way, we will have two primary key, two as a primary key, which is a part from the relation plus X becomes a new primary key. This one only X. Okay, even me now miss this point. How to make it much easy? To make it much easy, if you have this problem, this you see this same here. Okay, same idea. We have this problem with BC and F. Yes, it's first okay, second okay, third okay, because this determine part from the key. But BC and F not okay. Then what's the simplest solution? This one. You take C as part from the primary key. Then you flip between C and B. So C become, instead of B, the part from primary key, and it will determine B and D. But you have to keep this one. This become partial dependency. Instead of a problem with B, C, and F, now the problem with which one? With the second normal form, yes? What's the problem with the second normal form? Partial dependency. Third normal form, transitive dependency is a problem. Yes, so it's simple, very simple. Just if you have like this one, non-primitive attribute, determine primitive attribute, you take this non-primitive attribute as part from the primary key, and this one become non-primitive. And you keep this FD 2. We make only small change with FD1. What's the small change here with FD1? C takes the position of B here. You understand this point?
Yes, Doctor, yes.
Then now the solution becomes simple. It's not in the second normal form. How to make it second normal form? You take out B with copy from C with the functional dependency. This one, we take it here. What remain here? A, because here we take copy from C, but B we take it out. So we have A, C, and D with the functional dependency and this one. And now we know that C it's the primary key and A, C is primary key. It's in the third normal form, and B, C, and F now. So this more simple solution, yes? So if we applied this here, to delete like this. If we applied this way here, it's difficult to write, but I will write it like this. I will convert this first step. We will take student ID. It will be difficult to write inside this. Let me use this. Okay. Student ID. Okay. Now instead of a professor ID, I will take the class code. Okay. Now professor ID will take the place of a class code. And student grade will stay here. Now what about the primary key? It will be class code with student ID and this functional dependency as it. Class code determine professor ID. Class code determine professor ID. And this functional dependency same also. We have the primary key student ID class code determines. Okay, I know it's now simple. This one partial dependency will take it out. We have primary key with this one. Okay, class code with the professor. We still have here student ID with the class code as primary key and the remain attribute its student grade. Now we solved it. We solved the problem, was confused about the primary key for both relation and make it much simple. Now if you check the new solution, okay, it's full functional dependency, so it's in the first normal form, no partial dependency, so both will be in the second normal form. We don't have transitive dependency, so it's in the third normal form. We don't have functional dependency that we have non-prime attribute determine prime attribute, so it's on BCNF. This is the solution. Which solution you think better? Okay, I think for me, I prefer the easy way like this, but the formal way, it's following the algorithm. We have X determines A, cause the problem. Then we take R minus A. This new relation R minus A have primary key, the original one with X. The original one plus X. Okay, second relation, X union A. The primary key will be also only X. Okay. So this the way to solve this issue BCNF. Try this one at home. Okay. We finished this one. We will continue with SQL. Maybe we can have only 5 minutes break.
Okay, Doctor.
Yes,
Okay.
doctor. Okay, doctor.
Just 5
Okay,
minutes break.
Okay, doctor.
Assalamu alaikum.
وعليكم السلام.
Okay, we continue. Now we will start with the new chapter, chapter 6, about basic SQL. First, with basic SQL, we will apply some queries using PostgreSQL. So you can download BG admin from this link to try all the queries, okay? And you can also see some document or instruction about BG admin from this link. So it's good if you download it after this class and you try the queries that we will take, and also it's good to try the queries from the book. Also, I will send to you our database. It's a company database SQL file. I will show you how to just import it using BG admin. So you will have the database that you will apply all the queries on it. Okay. So you just follow the link, download the BG admin. It's like any normal desktop application. You will just download it and follow the wizard. Then after download it, when you open the application, it will open like a web page for the DBMS, Database Management System, for PostgreSQL using this environment. Actually, there's many environments, but this is the most famous environment to manage PostgreSQL. And this some instruction how to use the application itself or documentation. Okay, first we will speak about the data definition language with SQL. From it, data definition language, this means how to define your database, your schema, and the bus of your schema, like tables, attributes, domain, views. We will speak about all this. So now, when we speak about SQL, we start to speak about the relational database itself, not about relational model. In the relational model, we names relation, tables, attributes. Now in SQL, we will use the names table, row, and columns. Table, which equivalent to relation, row, which equivalent to tables, column, which equivalent to attributes. Okay. So data definition language, the statement to create database and its content. Okay, first thing, we speak about the schema and catalog concept. Of course, there's many relational database management system already exists. The most famous one, Oracle, DBMS, SQL Server, also it's a relational DBMS. We have also for the web, especially with PHP and some web development language. We have MySQL. Even we have some simple relational database systems like Access from Microsoft. Also, we have the PostgreSQL. Why PostgreSQL? Because it's open source. Okay. For example, if you want to buy a relational database management system like Oracle or like SQL Server for your company, you speak about hundreds of thousands or even sometimes million to buy this systems. Okay, but PostgreSQL it's open source and free to use. Okay, that's why we will use it to apply our query during our course. Okay, database usually have one or more schema. So when we speak about database, our database and the schema it's part from database or the whole database could be equivalent for schema. So schema may contain one or more database may contain one or more schema with different users and privilege. So the schema usually have authorization identifier. This schema authorized for which users or which privilege, and description for this schema. The description for the schema contains tables, constraints. We will speak about constraints on the tables. It's very important. We have constraints for the attributes. We have constraints about the table, about key constraint, referential integrity constraints, and entity integrity constraints. I think all these terms we spoke about it before. Views. Actually, views, it's like it's not a table. It's like a temporary table that have result from queries, especially join, and this type of query, it could be or this view, it could be dynamic or static. We will speak about it in details. Domains, when you define a specific domain and use it in the tables as data type for your attributes, and many other things. We will speak about each one when we reach it. Each statement in SQL should end with semicolon. So here, to create database, we could use this form, create database and database name. Then we will give some information and about database after with. This means with this attributes or this option. Owner, we will have the user here. Encoding, UTF-8. Actually, encoding, it's important to about the encoding for the information inside database. UTF-8 will allow you to add information in any language, almost Arabic, English, and other information. Connection limit, how many connection could be accepted at the same time for your database. Actually, some DBMS have its limit. When you mention that it's -1, this means it's unlimited. So if as much user as possible at the same time connect to your database, it could work, okay? But sometimes we make limit to protect our database from some problems like DS, okay, attack, and I think for PostgreSQL the limit 115. 15 only allowed for the database administrator. For the normal user, it's the maximum 100 connection at the same time. But you can go to configuration in the PostgreSQL and change it manually, actually. So in short, create database name, and then the owner of the database, this owner username or something like this, and the encoding and the connection limit. Actually, most DBMS, you will create database only with few clicks, like here in PostgreSQL. Let me go, which one?
Doctor, what do you mean by connection limit?
I mentioned it. Connection limit, how many connection allowed, how many user at the same time can connect to your database.
And that means
-1 means unlimited.
Does it mean web-based application? Does it mean user to the database?
No, actually, any database, you have the idea like a client server, because usually database will be in the server, database server, and many clients can connect to it. It's not in one standalone computer. Any database could usually have a client server. Yes?
Okay, clear, doctor. So
Yeah.
-1, it does mean unlimited.
Yes, unlimited. But even if you use -1 unlimited, most database management system have its own limit. So it's mean unlimited until the limit that allowed by this DBMS. Okay?
Okay, doctor.
I mean, there is a maximum limit from DBMS itself. For me as DBA, I write it's an unlimited, but DBMS itself limited me.
Understand. For example, 250 or 100, depending on the designer of the DBA MS.
Yes. For example, in Postgre, the maximum 100 connection at the same time. But you can change it manually. As DBA, database administrator, you can go to the configuration file and change the limit. But you will have a problem with the memory and other issues, so you need to change not only the limit, you will have some other configuration issue to do. It's not our job now, okay?
Clear, doctor. Thank you very much.
Just you have to know about the connection limit here. So, here's the documentation for PG admin. As I mentioned, here you have the menu and you can find everything, how to download, how to use it, and details. It's not our job now to speak about it. You will find it as a very normal software to download and use it. We will speak about the query most of the time, not about how to use the software PG admin to manage your database, because it's as any normal software, just some clicks and wizard, you can read about it. Okay, so if we have this the main page for PG admin, you can create your database here, the server, and here databases. Already have 2 databases. Let me delete this database, just to drop it. Tomorrow we have okay, it's being processed. Okay, I think because this one already opened, do not save. Save. Okay, I will only drop this one because tomorrow have programming language 2 exam, so students thought they have the I should be available 24 hours for them. Okay, database, create database. You can use query, but here query not available before creating database. So we just create a database. We give database name. We will see the SQL. You can write SQL here, or you can just follow the wizard. Maybe I will name it company database. This is the owner, and you can define the security privilege and grant some privilege for users. Okay, this is SQL. This is the default user. Okay, you can read about making more user and grant a privilege here for users. Okay, just save. We created database. It's still not connected. Just refresh. Okay. Here there is a default schema, which is public for all users. We can now use a query. Okay, that's the position that I want to reach. I don't want to describe everything in PG admin. We will use this one query to run our queries. For example, create a schema company. Let us create a schema. We take this one. Okay, create database. We see it. Create a schema. As I mentioned, database could have more than one schema depending on the privilege or authorization. You could make more than authorization on your schema, or more than schema. Each schema authorized for one type of users, okay, or a group of users. So you can have more than part. For example, you have this part from your database for accounting people. You have this part for manager people. You have this part for just data entry people, and so on. We will not use more than one schema. We just will focus how to apply our SQL statements. So we will just here create schema as example on how to create a schema. It's normal. Create schema. By the way, SQL, it's in case sensitive. So you can write small or capital about the keywords, but about the attributes, name, attributes, content, values, it's case sensitive. About the keyword, it's insensitive. So you can write a small or capital letter, but the people usually use capital letter for keywords, okay, in SQL. So we create a schema. We can name it anything, company, for example. And we have the authorization. Okay, authorization. There's one type error. Let me write it. I don't know where is authorization.
Delete the letter A. Yes, delete it. A.
This one.
Yes.
Yeah. Authorization. Okay. Authorization. And we have here the main user, which is Postgre. Postgres. Okay. I think this one should be between quotation. Okay, now we created new schema. This you need to make refresh. Here's a new schema. Okay, so we have now two schema. Then any query, we will just write it here and apply the query. It will be run on the database. Okay. After creating schema, what inside the schema? Tables. And tables have table name, have attributes, and each attribute have types, have some constraints for this attribute. Like if this attribute can be null or not null. Like if we have initial value for the attribute, like the primary key, which it's about entity integrity. like the foreign key, about referential integrity also. So creating tables, it's like this: create table, the name of the table. And we have here two ways. We could mention the schema like this. If we have more than one schema, we can mention the schema, so we know on which schema we will build our table. If we have one schema only, it's okay. We just mention the table name without the schema name. If you did not mention the schema name, it will take the default schema, the public one. Okay. So create table, this keyword, create table, and the table name. This is the most important. After that, if you have a specific schema, you can specify the schema by schema name dot table name. Okay, this is a relational database that we will use with our examples, and this database state. After see how to create table and blah, we will just import it. Okay, here example for create table. Create table, table name. Then we open practice and start writing the attributes, data type, and any constraint. Here we have not null. If you did not write not null, the default will be null. What's the meaning by null? The meaning by null, the allowable value. If you did not enter value, it's okay. If you make the constraint not null, this means it's not allowed null value. Okay, so you cannot leave b name here empty. This is the mean of not null. But b location, you can leave it empty because you did not specify. If you write null, okay. If you leave it empty without mention null, this means the default will be null allowable here. You can leave it empty. Okay, about data type, there is many of data type in SQL, like int or integer, like real number, like double, like character, like varchar. Varchar means, if we will speak about like programming, it's a string, yes. Okay, so if you have string value, like bit also, bit string, this means a string of bits, 0, 1, each element in this attribute, or each digit in this attribute. Okay, like a blob, this data type blob, we will see it. It's allow you to store data in one attribute until 10 gigabyte. So a blob usually used if you want to store multimedia attribute like video, like picture inside your database. But believe me, it's very bad to do this, because your database will become very heavy. Okay, so how to store pictures or video we usually store just the link for the video or for the pictures. We don't store the multimedia files like this inside our database because it will make our database very heavy. And also we can define the primary key like this, or directly you could write like this: b number, integer, not value, and before this comma, between each element definition you have normal comma like this. You can write its primary key. So this equivalent to this. You can write the constraint for any element separately like this or in the same line. Even unique p name, you can write it without like this, directly here. You can write it. After writing it, you put the comma, not before. So you know that this constraint for this element. Okay, about foreign key, like this, you mention the key inside, or the foreign key inside your table, and where is the reference for it? The reference for it, department, this means another table, and what's the attribute inside this department. Of course, if primary key 2 elements, then you will write it like this. For example, if I have b name and b number as a primary key, not only one. So like this, b number, comma, b name. Close it, then the comma. Okay, this okay, I think it's where is it? Here. This one. Okay. This the continue for creating the database for the company. Okay, you can see another type of data type like date, like character. This means only one character. Like character with numbers, this means we have a number of characters. Decimal, if we have a decimal point, like this mean 10 point, this mean 10 digits, point 2 digit. Okay, here also primary key, we have foreign key. We will return for the primary key, foreign key, and unique another time. You have here this link to show you all the data type, describe all the data type for Postgres SQL. You can follow this link to find all the data type. We will speak about the basic data type and we will stop. Yes, we late, but I become tired and I think all of you enough, yes. So we will speak only about data type, and we will import our database to show you how to import it, and I will give you the file so you can download the BG admin and import our database so you can apply all the queries after that. Okay, so basic data type we have for numeric data type for attributes. Yes, attributes have data type. We have integer and int, it's same. You can use integer, you can use int. Small int, it's about number of digits only, or number of bytes for this number. And we have real numbers. We have float, real, and double, and decimal also. If you have decimal point like this, if you want to define decimal point. Character string, we have character. This we have fixed lengths from the DBMS itself, so it will not be long enough. If you need string, long string, 30, 100, you can define. We usually use for string varchar. Char varying, it's similar. But everywhere you will find varchar because it's much easy. Everywhere you will find int, not integer. Why? Because it's short and much easier to write it. Okay, so all this similar, but we usually use varchar. And this too similar, but we usually use integer. Okay. About bit string, it's a string that take 0 or 1 for each digit. Blob, binary large object, it will take until around 10 gigabyte for the attribute. So I mentioned that before. It's usually for storing multimedia data, and it's better not to store multimedia data inside the database because your database will become very heavy. Boolean, it will take true or false. Date, data type, it's storing date. Okay. For data type, we have also timestamp. Timestamp will have date plus time. Okay. So we have date, we have time, we have time stub or interval of date. Okay. I think because domain need some examples and description, we will stop here. We will start from domain on Monday, inshallah. So let just now import this one. See, I will give you this SQL file. Okay, where is lecture note? This one, SQL file. I will give it to you after you download and create database. You can just easily okay. You just easily now, let me open new one. You can just easily open. You have to be inside the database, because if you are here or in another place, you will import here. You will see here which database. Company database. You are connected to company database. Okay. Inside your a query editor here, So now you can open any file. Okay, we will open our file database. Okay, lecture note, and we have our file. Then you'll find the place and our file, select this the whole queries to create our file, our tables, and of course we will see how to do each one of this. Create table, we already saw it, but I speak about the constraint and inserting data and everything here. But because we need the whole database to be around us to run our queries. So after that, just run like this, execute. Now you will have the database here. Of course, we did not mention the schema. That's why it will be in the public schema here. All the tables, department, dependent. Okay, if I want to check, for example, select star, this means all from department, for example, or project. This just select a statement to get all the data from table project. We will take it in detail after that. Run. Okay, here you can find all the data that we already added. This is the result, output. Okay, inshallah, next week we will continue and we will speak about domain, about constraint, how to create all the constraint in the database. Then after that, we will speak about retrieval using a select statement, inshallah. See you on Monday. That's all for today. Good night for all of you. I think
Thank you, Doctor. Good night. Thank you.
we already exhausted, yes.
Thank you, Doctor.
Okay. See you, inshallah. Good night. Assalamu alaikum.
Thank you, Doctor.
Alaikum assalam.
Assalamu alaikum. Thank you.